9 days. That's all that stands between us and a historic moment. Last week, NASA released new images of 3I Atlas, and what the telescopes are seeing now challenges earlier assumptions. The interstellar comet isn't just out there, it's active, bright, and showing behavior that's surprising scientists. Let's start with what happened last week. On December 4th, NASA and the European Space Agency released new observations of 3I Atlas, and these images tell a fascinating story. The Hubble Space Telescope photographed the comet again on November 30th, this time from a distance of 178 million miles. What we see is a bright, active nucleus surrounded by a glowing coma of gas and dust. The background stars appear as long streaks, direct visual proof of this object's extreme velocity. But even more impressive are the images from the JUICE mission. This ESA spacecraft on its way to Jupiter was in perfect position in early November, about 41 million miles from the comet. And what its cameras show surprised scientists: two distinct tails. The first is a plasma tail, electrically charged gas carried away by the solar wind. The second, fainter but visible, is a classic dust tail. What makes this remarkable is the level of activity. This is significantly stronger than expected for a comet at this stage of its orbit. The ESA put it carefully: "We are surprised by the activity level." But why does that matter? Why is NASA mobilizing every available telescope? Now here's what's truly extraordinary. 12 different NASA missions are observing 3I Atlas simultaneously. 12. That has never happened in the history of space exploration. Not with Halley, not with Hale-Bopp, never. NASA is throwing everything it has in space at this object. Why? Because opportunities like this are extraordinarily rare. Hubble and James Webb are providing the most detailed images. The Mars orbiters, Reconnaissance Orbiter, MAVEN, even the Perseverance rover on the surface, all observed the comet during its Mars flyby in October. The Psyche spacecraft, on its way to the asteroid of the same name, made observations over 8 hours. The Lucy mission, heading to the Trojan asteroids, captured it from 240 million miles away. And then there are the solar observation missions. Parker Solar Probe, Stereo A, SOHO, Punch. They all documented 3I Atlas as it passed behind the sun in October, invisible to us from Earth. This massive effort exists because this is only the third confirmed interstellar object we've ever observed. Oumuamua, in 2017, came and went before we could really react. Borisov, in 2019, gave us more time but limited visibility. 3I Atlas is different. We had months of advance warning, we have the technology, and we're using every available resource to gather as much data as possible before it disappears forever. So what exactly are all these instruments finding? What's in the data that's worth this unprecedented effort? The chemical analysis by James Webb shows high concentrations of carbon dioxide and methanol, about 40 kilograms of methanol per second streaming into space. That's more than average comets from our solar system. Interesting too is the timing. This outgassing began back in May, when 3I Atlas was still 6.4 astronomical units from the sun, far outside the zone where comets normally become active. That challenges conventional models. The size estimates have been refined. The comet's nucleus is between 440 meters and 5.6 kilometers in diameter. That makes it larger than the two previous interstellar visitors combined. At its closest approach to the sun in late October, it was moving at 246,000 kilometers per hour, the fastest natural object ever measured in our solar system. Its orbit is nearly perfectly hyperbolic. The eccentricity is well above 1, which mathematically confirms this object is not gravitationally bound to our sun. It came from interstellar space and it will return there. The orbital inclination of 175 degrees means it's moving retrograde, backward to the orbital direction of the planets. It came from the direction of the constellation Sagittarius, near the center of the Milky Way. New modeling suggests it may originate from the so-called thick disk of our galaxy, an older population of stars. Now, with 9 days left until closest approach, these unusual characteristics raise an inevitable question, one that some scientists embrace and others dismiss outright. And then there's the debate that's been running since July. And this is where it gets interesting. Avi Loeb from Harvard published a scientific paper asking, could 3I Atlas be artificial in origin? His arguments include the trajectory passes unusually close to Venus, Mars, and Jupiter. The object showed a blue coloration during perihelion, bluer than the sun, which is unexpected for a dust-surrounded body. There are reports of a so-called anti-tail, material apparently pointing toward the sun instead of away. And the brightness increase near the sun was stronger than typical Oort cloud comets. Loeb lists 9 anomalies, 9 things that don't quite fit. Individually, each one is explainable, but altogether, he says the probability is vanishingly small. And then comes the question many don't want to ask: what if he's right? Now here's where we need to be clear. The opposing side, represented by most planetary scientists, is unequivocal. NASA confirms it's a comet. The coma is visible. The tails are visible. The chemical composition fits a body made of ice, rock, and frozen gases. The outgassing is documented. Jason Wright from Penn State, himself a SETI researcher, has publicly criticized Loeb's interpretations, pointing out that each of the so-called anomalies has natural explanations. What's my assessment? The scientific data clearly shows we're observing a natural object. The fact that it's unusual doesn't make it artificial, it makes it interesting. And that's precisely why we're observing it so intensively. But here's what makes good science. We ask the question, we gather the data, we follow the evidence. Loeb asks provocative questions. That's fair, but the answers from 12 simultaneous missions, from spectroscopy, from detailed imaging, they all point the same direction. Remarkable comet, not spacecraft. Still, 9 days from now, all eyes will be on one specific moment. What happens then? In 9 days, on December 19th, 3I Atlas reaches its closest point to Earth, 270 million kilometers. That's 1.8 astronomical units, roughly twice the distance between Earth and Sun. There is absolutely no danger to our planet. At that time, the comet will be on the opposite side of the Sun from us. For observers with telescopes, it will be visible in the pre-dawn sky with an estimated brightness of magnitude 10 to 11. That means with an 8-inch telescope under dark skies, it's detectable, but not with the naked eye. The intense observations will continue. Hubble will make more images. The JUICE mission will transmit its high-resolution data to Earth in February. Only then will we see the complete scientific yield from 5 different instruments. In March, 3I Atlas will pass Jupiter at about 50 million kilometers distance. After that, it leaves our solar system and returns to the interstellar space from which it came. You and I, we witnessed humanity's first steps into space. We saw blurry dots on photographic plates become detailed images of distant worlds. We lived through the transformation from science fiction to science. 3I Atlas is a messenger from the depths of the galaxy. Not sent, not intelligent, but a messenger nonetheless. It carries in its chemical composition, in its ice, in its rock, information about places we will never reach, about star systems that formed billions of years ago, perhaps long since gone. In 9 days it flies past us. For one cosmic moment, it's our neighbor. Then it will return to the silence of the space between stars. But the data we've collected, the images we've made, they will remain. They'll help us understand that our solar system is not an isolated place, but part of a larger, dynamic universe. You remember July 20th, 1969. The world held its breath. We looked up together. On December 19th, no human will stand on foreign soil, but we will observe together as a messenger from the depths of the galaxy passes by us, and we'll understand the universe is bigger, older, and more mysterious than we ever imagined. Some will say it's just a comet. Others will ask, but what if it's not? And that question, that curiosity, that's what has driven us to the stars since Apollo.